In this section, we are going to discuss while loops. Each execution of the loop body is called an iteration. That is a technical term that will be used in the book and in the lectures. All it means is that the statement representing the loop body is executed one time. The fundamental characteristic of a while loop is that the loop continuation condition is tested prior to executing the body. This means that the body may be executed 0 or more times. 0 times because, like a selection statement, if the test is false, the statement is not executed. If any loop execution flow control is contained within the body, ensure that the update section is executed for that iteration to prevent an infinite loop. This is especially true for the continue keyword. The while loop, when executed, immediately tests the continuation condition to see if the loop body should execute at all. Usually the body is a compound statement, so the curly braces will be there. If the condition is true, the loop body is executed. The body should contain an update section to drive the loop control variable towards termination. Not doing so can cause an infinite loop. That would look like your program has hung doing nothing, or it will continue to output a significant amount of data in a never-ending flow. The example at the bottom shows all 4 sections. The loop control variable I is initialized to 0. Then it is tested to see if it is less than a number, in this case 2. If true, and it will be the first time, we print out hello world. The loop update section is changing that loop control variable to push that continuation test towards failure. We add one to it. Since the test was true, we executed the body. We now go back to the while test and we test is I less than 2. Because of the update section, I will be 1 now, and that is less than 2. We again print out hello world and increment I. I is now 2. We go back to the top, we test is I less than 2. In this case, is 2 less than 2? The answer is false. The loop terminates. We go to the statement sequentially after the curly brace that finishes up the while statement. Some loops are controlled by a count. We know how many times the loop should continue. We compute that value and loop that many times. However, some loops have no concept of how many times to execute. What we do is we look for a special value that when found, we terminate the loop. Our loop control variable is usually input from the keyboard and then tested in the continuation condition. A sentinel is the name given to that special value. It is consistent with the data type. That means if we're inputting integers, we must have the sentinel value be an integer. The sentinel value must be inconsistent with the problem. For example, if we're inputting quiz scores, we can input anything between 0 and 100. Those are valid quiz scores. Now with bonus points, it may be that 101 or who knows how many points could also be valid. Kind of an odd area to put a sentinel value because we can never guarantee what that score will be. Negative values like -1 would make a good sentinel value because we can't make negative test scores. A good example to think about is Fahrenheit temperatures. Assume a loop where we're inputting Fahrenheit temperatures and converting them to Celsius. What would be the sentinel value? It's conceivable that Fahrenheit can be in the many, many thousands of degrees. So that isn't a good area to put a sentinel value. Some people may react without deep thought here and say, why not the value 0? The value 0 is legitimate for Fahrenheit temperatures. Anyone who lives in the more northern climate realizes 0-degree temperatures happen every year. Negative numbers are also valid for temperatures. -44, for example, is a very cold temperature, but still it's achievable. In fact, what you have to do for a sentinel value for Fahrenheit temperatures, unless otherwise explicitly stated is you have to go to a temperature below absolute zero. So you would look up absolute zero, discover its value, and then choose a value less than that. And that would have to be your sentinel value. That is a value that is consistent with the data type, not with the problem. No Fahrenheit temperature can be colder than absolute zero.